Okay, hi everybody. I just wanted to talk to you guys a little bit. I'm going to try to do something different today. I'm going to try to show you a drawing that I did. I'll kind of walk around through it. So right back here is seafloor spreading. I wanted to talk to you about seafloor spreading because it's one of the units that we are going to talk about that goes into how plates move. Okay, so if you look right here, this part right here, looks like you guys can see that just fine. We talked about the mantle. This is the mantle right here. Okay, the lower part of the Earth. Okay, it's the lithosphere or the asthenosphere. What ends up happening is that this mantle is moving very, very slowly, and that convection currents, which is this right here. So this here is really, really hot right here, okay, because it's closer to the core. And then when I look, let me grab a pencil real quick here, a pen. As it gets further away from the core, what ends up happening is it cools down. Okay, and this is where we get the idea of convection currents. So what's ended up happening is that then it cools and then it goes like this here and it gets warm, it gets closer to the heat and it keeps going like this here. Well, what's happening is that there's convection currents all throughout the mantle. And what's happening is that it's moving very, very slowly. What ends up happening is that this is a drawing of the ocean. Okay, so underneath the ocean, we have oceanic crust. Okay, this is the oceanic crust right here. My recommendation is that while I'm doing this, you might want to stop and grab a pencil or grab a piece of paper and pencil and kind of either number one sketch this and number two listen to what I'm saying and make those notes. Okay, so this here is oceanic crust. This represents oceanic crust. As you can see in my drawing here, I've drawn it kind of thin compared to the continental plates or the continental crust over here. Okay, there's a continental crust over here as well. Okay, so what's happening is that all these crusts are moving. Some are moving away from each other, some are moving towards each other, and some are moving past each other. Okay, I've done a little drawing up here. Okay, converging boundaries, meaning that they're moving towards each other. Okay, what's going to end up happening is that if they are converging towards each other, they are going to, if they're the same density, okay, so like two continental crust, they're going to form a mountain. Okay, so this is a representation of two. You see my arrows there. They're moving towards each other. This is a converging boundary. Okay, that's a mountain. We then also have what's called a transform boundary. These are when two boundaries are going past each other. And as they're going past each other, a little part of one of the other of the boundaries may grab a hold of each other. And this is where an earthquake takes place. Okay. Then we also have what's called divergent boundaries. So we have three different types of boundaries. So a divergent boundary is where we would find a volcano. Okay. So these are two oceanic crusts, could be two continental crusts that are moving away from each other. And it's likely that what would end up happening is that we would end up getting magma coming in between those two crusts that are moving from each other. So this is a boundary. So what I've drawn here is called the mid-ocean ridge. Okay, this is a long ridge in between, like in the Pacific Ocean, where there is a ridge. And what's been happening is that this is what we would call the Asian plate, and then this is the North American plate. And they're moving away from each other. And as they're moving away from each other, magma down here is slowly creeping up and it's coming up and then forming in this area right here. And as we know, magma goes to the surface, whether it's in water, whether it's on land, it cools. And when it cools, it creates new land. Okay. This is where we would get new land. Okay. Now, as it's going this way here, this is going to move this way here, and this is going to move this way. It's not because this magma is pushing up; it's because of these convection currents in the mantle. Okay, so This is moving this way, and then this is moving this way. Okay, so a couple things. First off, when this plate is by a continental plate, okay, this continental plate is less dense than the oceanic plate because it's more dense. Okay. So what ends up happening is that this plate gets to the continent and it ends up going down in underneath the continental plate and it goes down into what we would call the mantle. Okay. This is called a subduction zone. Okay. This subduction zone is a place where actually I could draw in here. This would be where we would find some magma or we would find lava also, okay? So this subduction zone is also called a deep ocean trench, okay? So it goes down into the mantle. Okay, what ends up happening is this keeps on cycling over and over. So this here is about 200 million years old, okay? This here is new rock, okay? So the closer we get to the mid-ocean ridge, the newer the rock would be. So this rock is moving this way and this rock is moving this way. Okay, so the same thing would happen. This gets older over here. And so I've made a drawing over here where we can see magma is being pushed up because of the subduction zone. Okay, this is a subduction zone right here also, just like this is over here. And ends up going down underneath this mountain right here. And what ends up happening is like in the Andes, we have volcanic activity. So this is pushing lava up and over this mountain, and then there's big explosions. Okay, there's a lot of magma activity in oceans and then on land as well. Okay, so a lot of volcanic activity in those places. Um, so the density of the ocean plate is seen that is much, much denser. Okay, so now we know that Wegener said the hypothesis was that the plates were moving or the continents were moving away from each other and towards each other. And he kind of had a theory. And the theory was based off of climate and it was based off of landforms and it was based off of fossils. Well, then as we got further into the discovery of these plates moving, scientists became more aware and had more technology. They came to understand what we call plate tectonics. Okay, now this plate tectonics means that these plates are moving away from each other, and one of the things that they were able to do is that they were in an ocean, they were able to drill down into and get some evidence. Okay, so that would be primary evidence. Okay, direct evidence, and they were able to drill down into the ocean's crust. Okay, now, one thing that they found was is that the magnetic field was different from different places on the Earth's crust. Okay, so when they dug down, we could find that there was a magnetic field of this rock right here. And what happened was they theorized that what happened was that the magnetic field flips every once in a while over millions of years on Earth. And so they were discovering that at this distance here, from here, and then this distance from here was the same magnetic reversal. And then they would go the same distance away from the mid-ocean ridge, and they would find the same thing, that the magnetic field had changed, okay? This was their theory as to, or this was their evidence that proved plate tectonics. So what it did was it just reemphasized that Wagner was correct in his hypothesis. Okay, so new ocean floor every 200 million years. Okay, so every 200 million years we get this is the oldest rock crust on Earth. It ends up going down and going into the subduction zone, and then it ends up coming around, and then we have magma being pushed up, and it just keeps doing this over and over. It's kind of like a cycle. Um, so I think that's pretty much all I wanted to talk to you guys about today. I'll put this video on. It's a little bit different, as you can see. I'm doing it from my house. So what I'll do is I'll put this on, and this is going to give you an explanation of seafloor spreading and then also plate tectonics. Okay. Um, Hope you enjoy it, and I will talk to you guys later. We'll see you later. Bye.